Okay, welcome. In this video, I'm going to be working Algebra 2 Homework 8.2, and so we're going to be just practicing solving equations that have radicals in them. And I think what I need to remind you before we start is that when squaring both sides of an equation, you can incur extraneous solutions. So I'm just going to remind you that, you get an equation or you get a solution to these equations, you need to check it, right? So, all right, let's get started. The first one, I've got square root of 5x plus 1 equals 6. I'm trying to access x. That square root is in the way, so I'm going to square both sides. So the square root of 5x plus 1 squared equals 6 squared. I'm not going to show that every time. I might just say I'm going to square both sides and then get rid of the square root, but I just want to remind you, okay, that's going to be 5x plus 1 to the first power is equal to 36. I'm going to subtract 1, divide by 5, and I get x equals 7. Okay, I'm just going to quickly check, okay, and say, all right, that's the square root of 36 equals 6. I feel good about that. I'm ready to move on. Okay, the cube root of x minus 16 is equal to 2. Now, I'm not going to need to check my solutions because cubing both sides of an equation, if we're only looking for real solutions, is not going to incur any extraneous solutions. I don't even know that we can get extraneous solutions over the complex numbers. I haven't thought about that in a long time, but you definitely don't need to worry about that in this class. So I'm going to start by cubing both sides. And 2 to the third is going to be 8, so I've got x minus 16 equals 8, and x is going to equal 8 plus 16 is 24. Cube root of x minus 10 equals negative 7, so if I'm trying to get at that x, I need to get rid of this that's hanging on, so I'm going to add 10 to both sides, not the third root of 10. The third root of x is equal to negative 7 plus 10 is positive 3. And then I'm going to cube both sides, and I'll get x equals 3 to the third, which is 27. Again, cubing both sides on something I need to worry about is taking the square root, squaring both sides or taking both sides to the fourth power, because two numbers could be like the opposite of each other, and I could square them both and they could look equal. That's what causes the extraneous solutions in this case. So if I'm going to try to get at x, I need to really isolate this radical first, the square root of 24x. So I'm going to get at that by starting by subtracting 13. So that'll be negative 11 minus 13 is negative 24. And then dividing both sides by negative 2. Then I could square both sides. So I'm going to have to check my answer. And divide by 24. Well, hold on, am I in error here? Negative 24 divided by 2, that's 12, 144, 24x. Okay, does 24 divide 144? I don't think so, because it's 96. No. 96 and 48 is going to be 144. So it's going to be 6. Yeah, okay, pardon me. Because I didn't know that 24 times 6 was 144, but it definitely makes sense, because 12 times 12 and 24 times half of 12, yeah, okay. I'm feeling good about that. Now, what I need to do is check my solution. So I'm going to say, is negative 2 times the square root of 24 times 6 plus 13 equal to negative 11, so that would be negative 2 times 12 is negative 24 plus 13. Yeah, that's negative 11. That's good. Okay, moving on. And over here, same thing. Going to access the radical by, subtracting anything that was added on. So 15 minus 8 is 7. Then dividing by anything that was multiplied on. And then I'm going to take x to the fifth root of x to the fifth power, and I'll get x is 4 to the fifth. That's kind of a lot, but that's going to be 2 squared to the fifth, which is going to be 2 to the 10th. 2, 4, 8, 16, 20, 32, pardon me, that's 5 of them. 64, 128, 256, 512, 1024. Okay. That's probably not arithmetic I would ask you to do on a quiz or a test, but I will say that is arithmetic I've seen asked for in AP Calculus. So powers of 2, those are things that you can navigate, at least up to 2 to the 10. All right, this next one is x minus 6 equals the cube root of 3x. And I'm just going to go mention over here that I did not check my solution because I took the 5th power of both sides, not like the 2nd power, the 4th power, the 6th power, some even number power. So here on this one, this is one where I could see an extraneous solution popping up more easily because of, having to square the x. So I'm going to square both sides of this equation. So I'm going to have x minus 6 squared equals 3x. The thing is, I just have to remember to be careful about x minus 6 squared, because that's x minus 6 times x minus 6, which is x squared minus 12x plus 36. I just don't want you to forget that negative 12x. Subtract 3 more x. Right, and I have to think about two numbers that multiply to 36 while adding to negative 15. And no, that's going to be negative 12 and negative 3. So I can factor this. So I'll have x minus 12 times x minus 3 is equal to 0. And that could be true if x was equal to 12 or x was equal to 3. I'm going to check both of these because for some reason I'm not feeling good about the. Yeah, I see I've got one that's going to go bad. So for x equals 12, I've got 12 minus 6 is equal to the square root of 3 times 12. Yes, the square root of 6 is equal, or the square root of 36 is equal to 6. X equals 3 would be 3 minus 6 equals the square root of 9. And the square root of 9 is not negative 3, it's positive 3. Okay, so that means that x equals 3 is an extraneous solution, and I could cross it out, I could erase it, pretend it didn't happen. X equals 12, that's going to be my only solution. Now, I think this one's going to play out much the same, so I'm going to square both sides. And x minus 10 squared is going to be x minus 10 times x minus 10, which would be x squared, negative 10x, and another 10x, so that's negative 20x plus 100. I'm going to set this thing equal to 0 so I can solve it because it's quadratic. X squared, add 2x, that would be minus 18x. Subtract 44, so 100 minus 44. 100 minus 40 would be 60. So if I subtracted 4 more, that would be 56. All right. 56. I can think of 28 times 2, but that's not really working. But if I've got 28 and 2, I could pull half of the 28 over the 2 and have 14 and 4. That's gonna work. So it's gonna be negative 14 and negative 4. Yeah, 14 times 4, that does feel like 56. So x minus 14 times x minus 4. And if those things are multiplying together to equal 0, that would happen if x was equal to 14 or if x was equal to 4. And much like last time, I had to square both sides of the equation, so I'm going to check my answer. Thinking about the square root of, or x equals 14, the square root of 44 minus 28, 16. Is that equal to 14 minus 10? Yes, good. But when x equals 4, I'm going to be having the square root of 44 minus 8 equaling 4 minus 10, and that's not true. The square root of 36 is positive 6. That's an extraneous solution. I'm crossing it out. So x equals 14. That is my only solution. This one looks a little more exciting. Okay, I'm going to have to take both sides to the 4th power. So I'll have 3 minus 8x squared equals 2x taken to the 4th. And that's going to be 2 to the 4 times x to the 4. If I want to solve this equation, I'm going to need to set it equal to 0. And this looks like a lot, but I'm hoping this is factorable. Okay, because I've got that 4th power, 2nd power, no power pattern. We've worked with this before in this class. So I'd have 16x to the 4 plus 8x to the 2 minus 3. So what I need to be considering is, are there two numbers I can think of that multiply to 16 times negative 3 is negative 48, while adding to 8? Yes, it's going to be 12 and 4. Okay, so it's going to be positive 12 and negative 4. Okay, so I'm going to take that 8x squared, I'm going to split it up into positive 12 and negative 4. So I'm going to split it up into 12x squared and negative 4x squared, and then I'm going to be able to do group and factor on this. It'll just be a little bit challenging. Alright, so I look at the first two terms, and I say, alright, what can I factor out of them? Definitely an x squared, but also a 4. And I'd be left with a 4x squared plus 3. Ah, yes, and then I see that 4x squared plus 3 there. I'm just going to have to subtract a 1. 4x squared plus 3. Then, alright, I'm going to keep going. And yeah, I've got a little bit more room to work here. But I think I'm going to preemptively shrink that down. Because I know I'm going to need to check my solution because I took fourth power of both sides of an equation. Right, and I'll have 0 equaling 4x squared plus 3 times 4x squared minus 1. Alright. So I am expecting 4 solutions, and I'm going to be able to solve this for all 4 of them. The legitimacy of the complex solutions I'm not going to get into. We're just going to solve those and leave them as they are. And we'll show that one of the real solutions is extraneous. I think is how this is going to play out. Okay, but this could happen to be equal to 0 when 4x squared plus 3 was 0. Okay, so x squared would be negative 3/4. And x is plus or minus root 3 over 2 times I. We're just going to leave those as they are. We're not going to check those for if they're extraneous or not, because we don't take the fourth root of imaginary or negative numbers. That's what I'll say. This one we can solve out. We'll have 4x squared minus 1 equals 0. So I'd add 1 and divide by 4. And I'd get x equals plus or minus 1/2. Okay, x equals negative 1/2 is not going to work because if I did that, 8 times 4, I'd be having square root, or the fourth root of 1 equals negative 1, and that's not true. Fourth root of 1 is positive 1. So the plus or minus that's extraneous. So I'm just going to say x equals 1/2 is the only real solution. X equals plus or minus root 3 over 2i. Maybe those work, maybe they don't. You can kind of investigate that for yourself if you're interested. Alright, by comparison, this one looks really nice, so I'm going to divide both sides by 4. 128 divided by 4, well, it's like dividing in half twice. So 128 divided by 2 is 64, and 64 divided by 2 is 32. Then I take the fifth root of both sides of the equation, and I don't need a plus minus because it's an odd root, and the fifth root of 32 is just positive 2. Over here, oh yeah, okay, I like this one. So we're going to need to take the fourth root of both sides of this equation, so that is going to incur a plus or minus. So I'll have x minus 3 equals plus or minus the fourth root of 16. That's going to be x minus 3 equals plus or minus 2. I can just kind of solve for this. Wait, not negative 3, I'm adding 3 to both sides. And so I'll have 3 plus or minus 2, but I don't like leaving my solution there. I've got two solutions, I should write them separately. I've got x equals 3 plus 2, or I've got x equals 3 minus 2. And now we're going to check both of these, but I didn't square both sides of the equation. I took the fourth root of both sides of the equation, so that should be, I don't need to check. Right? That's when I'm squaring both sides. This is lately what's been kicking us extraneous solutions. In the past, it was absolute value. Now, really, it's two sides of the same coin. It's the same thing that's causing the extraneous solutions, but I'm not getting into that here. Okay, but with x equals 5, okay, we've got 5 minus 3 is 2 to the 4 equals 16, and with x equals 1, I've got negative 2 to the 4 equals 16, and both of those are true. So both of these are legitimate solutions. All right, here's another one. We're not going to be taking the square root or the cube, or no, we're going to be taking the cube root of both sides, but we're not like squaring or cubing both sides. So I'm going to take the cube root of both sides. And 64 is 4 to the third. So that's going to be 4 equals 8x, x equals 2. You can check your work. That's 16. Whoa, whoa, whoa. What have I done here? The cube root of 64 is 4, right? So 8x equals 4 and x equals 2. What's going on here? Ah, yes, I see. I divided both sides by 4, and I should have been dividing both sides of this equation by 8, right? Because then I'd had 2x equals 1. I divided both sides by x equals 4, not x equals 2. So I need x equals 4 divided by 8. That's x equals 1/2. That's another reason you should check your work. Just check silly, or you can catch silly mistakes like that. But 8 times 1/2 is 4. Yeah, 4 to the third equals 64. That makes sense. All right, let's move on. All right, the cube root of x to the 4 equals 81. Okay, let me tell you what I'm not going to do. I'm not going to take 81 to the third power. Okay, that looks like what they want you to do, but that's not going to be the way for us to go, because I don't know how 81 to the third power, that's going to be like really big arithmetic. And we don't need to do that. So what we're going to do is we're going to write this as a fractional power of x. So that would be x to the 4/3 equals 81. And if I want to get rid of a fraction power with an equation like this, I'm glad we had one of these. We probably needed more of these. I'm going to need to take both sides to the reciprocal power. So what I'm going to do is I'm going to take both sides of this equation and I'm going to take them to the 3/4 power. And so x to the 4/3 to the 3/4, that's just going to be x. And then I'm going to be k. Now, I should probably, all right, now, I guess that's something that I didn't think about for the lesson or whatever. But if I'm taking both sides to the 3/4 power, that's like cubing and taking the fourth root, so I am taking an even root of both sides of the equation, so I am going to need a plus or minus. So I'm going to include that plus or minus. I'm going to have 81 to the 3/4 power. 81 to the 3/4 is going to be the fourth root of 81 cubed. The fourth root of 81 is going to be 3, because it's like taking the square root twice. And I've got 3 to the 3, and so that's going to be x equals plus or minus 27. Now we can go and check if you're feeling bad about this, but think about it either way. If you take negative 27 or positive 27 to the 4th power, you're going to get a positive number. And I presume that that's the type of number that if we took the cube root of, we'd get 81. But we could also, take the cube root first and then take to the 4th power after, and we would see that we were taking 3 to the 4, and that's going to be 81. Or negative 3 to the 4, and that would also be positive 81. So both of these are valid solutions. Oh, whoops, wrong color. Right, now we're going to solve some equations that have two radicals. Okay, so I think the key is, if possible, we want to just kind of put the radical, radical equals radical, so we can just square both sides and have everything work out nice. This one's going to work out that way. I'm going to add that second root to both sides and say I've got square root of x, 3x minus 3 equals the square root of x plus 12. Then I can square both sides, and I get 3x minus 3 equals x plus 12. And this could definitely result in an extraneous solution if we got some kind of x that was causing us to take the square root of a negative number. But let's see, 3x minus 3, let's just maybe subtract 1x from both sides, then add 3 to both sides. So that's 7.5, and you can see that on any version of this equation, that's not going to ask you to take the square root of a negative number when x is 7.5, so this is going to be a valid solution. Alright, and this one's kind of unfortunate, because I'm not going to be able to, kind of get rid of this 1. So what I'm going to do, I'm going to square both sides of the equation, I'm just going to have to do it twice. Okay, so just strap up and prepare yourself because this one is not going to work out as nicely as the previous one. So I'm squaring both sides. So I'm going to have the square root of 3x minus 8, not 18, plus 1. I'm squaring it, so I'm going to multiply it by it a second time. And then wait, no, I squared the left side, and then I squared the right side, and I'm going to get x plus 5. Now, when I square this, I'm going to multiply the first two things together, and square root times square root is just the thing on the inside. So it's 3x minus 8. The outside and the inside are both going to give me one of these square roots. So in total, I'll have two of these square roots. The last two gives me a plus 1. Now what I'm going to do is I'm going to try to isolate this radical. And, okay, yeah, this is going to work out pretty okay. So I'm going to have, maybe I'll just kind of collect the 3x minus 8 and the plus 1 over here. So I'll have the 2 square root of 3x plus 8 plus 3x minus 7. And that's going to equal x plus 5. Now I'm going to subtract 3x and add 7. Subtract 3x, add 7. Divide by 2, so I'd have negative x plus 6. Starting to run out of room here. And now I'm going to square both sides, kind of like I did with, I don't know, I've worked one like that on this video. So it's going to be 3x plus 8 equals the square of negative x plus 6. So negative x plus 6 times negative x plus 6. I'm going to have positive x squared, negative 12x, and positive 36. I'm going to set this thing equal to 0 so I can hopefully factor, but if not, I'll use quadratic formula. It's not the end of the world. I'm not going to really like to check my answer with that, but I have faith. I think this will be factorable. Negative 12 minus 3 more is negative 15x. 36 minus 8 is 24. No, it's not. That would be 28. Okay, so 28 is 14 times 2. Hold on a second. It's also 7 times 4. Okay, great. I found it. I made a copy error. That's actually kind of a relief. That should be 3x minus 8 there, so this should be a minus and another minus there, meaning that this would be, instead of 28, it would be 44, and that'd be two numbers that multiplied positive 44 and added negative 15 would be negative 11 and negative 4. So I've got x minus 11 times x minus 4, and so my solutions are going to be x equals 11 and x equals 4. I'm going to go off to the side. I'm going to have to write pretty small to do my checking, but I'll do that in red like I have been. X equals 11 is going to tell me 33 minus 8 is 25. So is the square root of 25 plus 1 equal to the square root of 16? No. That would be 5 plus 1 is 6 equals 4. Okay, that's extraneous. But x equals 4. 4 times 3 is 12, minus 8 is 4. And 4 plus 5 is 9. Okay, 2 plus 1 is 3. Yes. Okay, so that's my solution. X equals 4. Okay, great. Okay, good. Here we've got a couple more that have fraction exponents. We need to solve that. That's something that I've always found that otherwise strong students in my calculus class sometimes struggle with. So what we're going to do is we're going to start by, kind of isolating the power of x. Since there's only one power of x, we can kind of apply the same principle we've applied throughout this course, is that if we have only one power of x, we're going to solve that x directly. If we have a mix of powers of x, we're going to have to set it equal to 0 and factor. We're only seeing one power of x here. It's x to the 3/4, so I'm going to isolate it. I'm going to start by adding 14 to both sides. Dividing both sides by 2. Okay, I see how this is going to go. Okay, if I've got x to the 3/4 and I want to access x, I'm going to need to take both sides to the 4/3 power. So I go over here, say that to the 4/3 equals this to the 4/3. So I'll have x to the first over here, and if I'm taking the cube root of both sides, I don't need to worry about a plus or minus. So I'm going to be saying, okay, 27 to the 4/3 is the cube root of 27 taken to the 4th, so that's 3 to the 4, and that's going to be 81. I did take both sides to the 4th power, before taking the cube root or after, however you want to think about it, so I should probably check, but I'm feeling pretty good about this because, okay, 2 times 81 to the 3/4 is going to be 27. Minus 14 equals 40. Yeah, that's true, because I got 54 minus 14 is 40. Yeah. Okay, good. X equals 81. That's my solution. So next one, 6x taken to the 2/3 is 36. So I'm going to take both sides because I've got the 6 inside the parentheses. I'm going to get rid of that 2/3 by taking both sides to the 3/2. But when I'm taking both sides to the 3/2 power, what I'm doing is I'm taking the square root of both sides and cubing. So when I take the square root of both sides of an equation, I do need to remember the plus or minus. So I'll have that in there. And then I'll say, all right, 36 to the 3/2 is the square root of 36 cubed. Okay, so 6 to the 3, we've seen that a few times recently, that's 216. I'll divide by 6, and I'll get x is plus or minus 216 divided by 6. Well, I don't know how to divide 216 by 6 without doing long division. And I really try to avoid that in this class. Try to do really anything else besides. So what I'm going to do is I'm going to try to divide in half and then divide by 3. Okay, because I can't really think of what 216 divided by 3 is. I know what 216 divided by 6 is. It's 36. Okay. Right? Yeah, because 6 times 6. Oh, goodness. Pardon me. All right. And anyway, let's make sure about this. Yes, those are definitely valid solutions, both of them. And because I didn't, square or take both sides of the equation to the 4th power, I don't really need to worry about checking my solution because I'm not, taking the square root or anything in the original equation. I'm taking a cube root, so I can take this cube root of negative 36. Okay, so those are my solutions. Here, with this one, I'm going to want to isolate the thing with the parentheses because I'm going to want to square both sides to get rid of that half power. So I'm going to start by adding 2x to both sides. Then I'm going to square both sides of this equation, so I'm going to get 5 minus x equals 4x squared. Now if I square both sides of the equation, I will need to check at the end, so that's kind of like something that's on my mind right now. But I've got a quadratic, so I need to set this thing equal to 0. So 4x squared plus x minus 5. I'm going to try to factor this, and I feel pretty good about my chances because I'm looking for two numbers that multiplied to 4 times negative 5 and add to positive 1. So I'm thinking positive 5 and negative 4. Yeah, there we go. So I'm going to split up that x into 5x and minus 4x. And then I'm going to do some group and factor. So I'll have 0 equaling what's common to both of these, just the x. And I'll have 4x plus 5. And then over here, just the negativity is common, so I'll factor out a negative 1. Get 4x plus 5, that's a good sign. Factor out the 4x plus 5. Be left with an x minus 1. And I've got this thing factored up real nice. So I've got either of these things could equal 0, and so that would tell me either x could equal 1, that would be the easy one to figure out, or I could say 4x plus 5 is equal to 0, subtract 5 from both sides, divide by 4, and say, all right, x would be -5/4. But because I did square both sides of this equation, I'm going to need to check my work here. So I'm going to go over here, maybe I'll check in blue, and I'll say, all right, if x is equal to 1, I have 5 minus 1 is 4 to the 1/2 power minus 2 times 1 is equal to 0. That's true, right? Because 4 to the 1/2 is the square root of 4. That's 2. 2 minus 2 is 0. Okay, if x is -5/4, I've got 5 minus -5/4. So 5 plus 5/4. 5 is 24ths plus 5/4. That's going to be 25/4. If I take that to the 1/2 power, I'd have 5 halves. Minus 2 times -5/4 would be plus 5 halves. That is also equal to 0. So, yeah, okay, both of these work. These are both valid solutions. That one was kind of weird on the checking the answers front, but we square both sides, we gotta check. So, glad that showed up on the homework, not quiz. Alright, so this last one, I'm going to take both sides to the 4th power. That's, again, going to cause me to need to check my solution. But I'll have 5x squared minus 4, once I take both sides to the 4th power, equaling x to the 4. So I'm going to set to 0 because I have different powers of x. I have x to the 4 and x to the 2. So I'm hoping to factor. Oh yes, great. So I've got a 4th degree polynomial. I should be expecting 4 solutions, and I think I can factor this with... Did I do that right? Yeah, okay, I did that because that was a group and factor one. So I'm thinking of two numbers that multiply to -4 and add to -5, and I think that would be... Wait a second. Would not be working, but I needed to add 4 to both sides. So now, yeah, okay, I've got -1 and -4. The thing with these is that it's just going to be x squared minus 1 and x squared minus 4. And you can look at that and kind of mentally foil and see how that would work out. Okay, but at this point, I've got my factors. I could go a little farther, though. It's been a while since we've talked about a difference of 2 squares, so maybe I should do that. A difference of 2 squares is something we can factor on. So I factor like that, and I've got either x plus 1 equals 0, x minus 1 equals 0, x plus 2 equals 0, or maybe x minus 2 equals 0. And because I did take both sides of the equation to an even power, I need to check my work. Okay, so I've got these potential solutions, x equals -1. Alright, so 5 times -1 squared would be 5 minus 4 is 1 to the 1/4 equals -1. That's not true. Okay, so that's an extraneous solution. Okay, when I've got x equals 1, I'll have 5 minus 4 is 1 to the 1/2 equals 1. That's true. Okay, that's a good solution. X equals -2. 5 times 4 is 20 minus 4 is 16 to the 1/4 power equals -2. No. Okay, 16 to the 1/4 power is the positive 4th root of 16, and that's going to be positive 2, not -2. That one's extraneous, but x equals 2, that feels right to me. Let's see, x equals 2, 5 times 4 is 20, minus 4 is 16 to the 1/4 equals positive 2, that's great. Okay, so these are my two solutions, x equals 1 and x equals 2. Alright, now on to the last page. So I'm going to start by, I think all of these just have 1 power of x in them. So, or something that's been factored up really nicely. So we're going to solve all of these directly. So I'm going to start by dividing by 4. Wait a second, I feel like we've solved some of these equations already. Yeah, I've definitely solved A, B, and C already in this video, so I'm just going to move on to D. But if you don't remember that, you should definitely do those problems again. They are, let me just scroll back up for you and show you where they were. They were I, J, and K. But it looks like L was slightly different. Oh, whoops. I may have put part of the upcoming quiz on screen, but that'll be all right. You know what's on the quiz. It's exactly like the homework. So, all right, skipping A, B, and C, moving on to D. We're going to start by subtracting 4 from both sides. Okay, I like where this is going. Dividing by 8. Taking the cube root of both sides. Wait, no. Cube root of x to the 3 would just be x. Simplified radical form, that's cube root of 3 over the cube root of 8. But wait a second, cube root of 8, that's 2. And so I would get x equals cube root of 3 all divided by 2. Alright, now we've got a contextual problem. Biologists have measured the shoulder height in centimeters of a male Asian elephant with the function h of t equals 62.5 t to the 1/3 plus 75.8, where t is the age in years of the elephant. Write h of t in radical form. Okay, gladly. So h of t, okay, I've got that fraction exponent, I just need to write that as a radical. So 62.5 times the cube root of t instead of t to the 1/3 plus the 75.8. Okay. What is the predicted shoulder height of a male Asian elephant at birth? Okay, well, birth means that its age is 0 years. So we're just going to plug in 0 for t. So h of 0 is going to be 62.5 times the cubed root of 0 plus 75.8. Plugging in 0 for t. Well, that means that the cube root of 0, we know that's 0, so h of 0 is just going to be the 75.8. And that's measured in centimeters. Okay, predict the age of a male Asian elephant with a shoulder height of 250. So if h is equal to 250, that means that 62.5 times the cube root of t plus 75.8 is equal to 250. You know, this one, I don't know, might require, I don't know if I would say requires a calculator. I'm just going to solve for an exact value, and you probably won't like what it looks like. If you want to get a better idea, you can use a calculator for this one. So I'm going to isolate the cube root of t by subtracting 75.8. I do think that's something I can do. So 250 minus 75 would be 175. So I've got 174.2. And then, wait, I still had a cube root of t that I've lost here. And now I'm going to divide by 62.5. But that's kind of where you're losing me. I don't know how to do that division. I mean, I could do long division, but there's no point in that. And t is just going to be this number cubed. And that's an exact number, and I'm not going to be pulling out a calculator in this video and figuring out, like exactly what that number is, but, I'd say it's probably somewhere around, 175 divided by 62.5, that's maybe a little bit less than 3, so 20-something, a little bit less than 3 to the 3rd, it's 27, I don't know. Some reasonable number of years. All right, what is the average rate of change of the elephant's height in centimeters per year for an elephant who grows according to this model over the first 10 years of its life? All right, so average rate of change, that's just a fancy word for rise over run. So that's going to be, change in age, change in height, divided by change in time. And notice, like measured in centimeters per year, that'd be the change in age is measured in centimeters, and the change in y time t, that's measured in years. There's no y in this problem. Okay, so this is going to be, first 10 years of its life, so h of 10 minus h of 0 divided by 10 minus 0. Unfortunately, I think, again, this is maybe assuming that whoever was working this homework had access to a calculator, and I don't really assume that in this class, so it'll be all right. H of 10 is going to be equal to 62.5 cube root of 10 plus 75.8. H of 0, we already found that. That was the height at birth. That was 75.8. Okay, so I guess we could, kind of just plug in on this formula. If you had like a decimal number for this, you could then use the calculator to do that number minus 75.8 and then divide by 10, but it's a different story. I'm trying to do this without a calculator, so I'm going to say, all right, if I take h of 10 and I subtract h of 0, I'd lose that 75.8, so I'd get 62.5 cube root of 10 divided by 10 minus 0. And so I could divide by 10, but it's like if I'm already working with decimals anyway, I might just call that 6.25 cube root of 10. And that would be, the average rate of change in centimeters per year, and that would be an exact value that you could come up with on your own without using a calculator. And that's going to be all the problems on this homework, so that'll be all for this video. Thanks for watching.